Um, So, welcome everyone. This is the extended version of the computational chemistry job automation workshop. And in the previous version of this workshop, we tried to have a geometry of H2 optimize, compute the frequency, and run the calculation with fireworks. And we tried to generate uh, a workflow which consisted of fire tasks within it, and then a workflow with multiple fire tasks. So if you miss some of this, you can go back and look at the videos that are posted on the Chemistry with Code YouTube channel. And in this edition, we are trying, we'll be doing something a bit more complicated. And that is, first we'll start with a sequential model, just to refresh what we did earlier, which is we'll start with optimization and then pass the then go to the next task, which is computing the Hessian matrix, and then finally doing a TDHF. And in the following workflows, we'll then see how a runtime error can be encountered in a workflow, and how we could raise an error if needed to stop the workflows in between. And we'll look at how to diffuse the workflows. And this is the case wherein you want to stop the workflow, but not kill the workflow. And we'll see what that means when we try to do it. And we'll then move on to passing parameters to the workflow. Initially, the previous workshop, we did not pass any parameters to the workflow between the fireworks. So in this, we'll look at that. And we'll finally move on to how to pass user parameters, like how to change the parameters that are encoded within it, within a workflow. And finally, we'll think of writing stuff to the DB. DB is a database, and so that we could search for the results that we actually want from the database. So if you have any questions, you can just ask me or type it in the chat, whichever works for you. So now let's get back to and for now we would need the files for the files, and those are on the GitHub on the GitHub page and under chemistry with code, and you can download them with the thing that I've sent in the chat. So once you have downloaded, please let me know, and I will start sharing the other screen in which we have Mongo connection. So these are the files that I've downloaded from the GitHub, and yeah, these are the modified versions of the files when you have some more things added into it. So last time we had the fireworks. Okay, this is PyCharm, and I've opened W flows in PyCharm, and this is what it should look like. And W flow is within the files, and this is the file that we use to create the workflows. But this is a modified version of it right now. So we have some added tasks into it, and there are multiple tasks. We'll go through them one at a time. But right now, make sure you make changes into the launchpad. And if you remember, from the last time, we had to copy that username and password from the MongoDB server that you created, and then pass it on here. So let me check whether this works for me. I've put it in there. So lpad reset. I have the Python environment, everything set up. So let's go ahead and see whether this works when I've made the changes. So you should get something like this. And this is a terminal in which I'm trying to run it. So you can open your terminal if you don't have a PyCharm and run it. So you should get something like this, which says reset 0 workflows. If you have workflows before, it will show you how many workflows are there, but you can reset all of them right now because we'll be doing something else with those. So reset, it'll show you Launchpad is reset, and you should be good to go. So we have 3 files. In the files, so we have chemistry automation folder, and within that chemistry automation folder, we have examples and then files. So I right now opened the Wflow tasks, and let me also open the one Wflow file. So if you remember, let's go to the tasks first. And the first task that we are trying to run is this one, when we have a sequential thing going on, which is we have optimization task, a Hessian, and then a TDDFT. So that task I have defined as a simple workflow. So in a simple workflow, we put in a optimization task, a Hessian task, and a TDHF task. So let's look at what the optimization task is. So if I go to tasks and scroll up to optimization task. Let me just minimize this. So optimization task is over here. So this code that you see within the run task is from the examples folder in geomopt.py, and you'll get this code over there. And what I've done is copy pasted that code into this file here. So let's see. Optimization. Okay. So I put in the code here. This code is copy pasted from the geom opt in the example files. And this is a optimization that we try to perform. And we have optimization, and then we print out the atomic coordinates. The second task in the workflow is the second task is the Hessian task, and finally there'll be a TDHF task. So let's quickly look into those tasks. So the second task is the optimization. Okay, this is the Hessian task, which we are trying to run. So Hessian task, again, the code is from the frequency.py. I've copy pasted it in here. We'll just print out the frequencies that we calculate from this. And finally, there is a TDHF task at the bottom of this, and where we are trying to do a TDHF. So we pass in the geometry within the task itself and try to run it, and it gives us some energies. Okay, so to run that task, we'll go to the run workflow, and within this, instead of launching my workflow, let me use the simple okay. So the files and everything I imported in here. So the simple workflow. And now I need to run this file. So I go back to my terminal. Let's see what's happening. So if you remember, if I now run this file, Python run, this gave me an error saying that files is not found. And that's because if you remember the last time, we had to set the export Python path. Python path, but that should be set into the chemistry automation folder. So you can go there and uh, export Python path equals to PWD. So in this case, what we are saying is telling Python, okay, we have this chemistry automation folder, and that should be added to your path, and that is how we get files dot something in there. So it means files is some sort of a module within a Python package. And in order to do that, we have to do something like this in the chemistry path, chemistry automation, and then go to files. And if I let me clear the screen and just run Python run. So as you see, a workflow has been added. And if you want to run, if you want to look at what is going on, you can always start the web GUI, and LPAD web GUI will start a browser for you, and hopefully it should open up in few seconds, and we can look at what it looks like once we have added the workflow to the screen. Let's wait for the browser to open. It doesn't want to open. Okay. Let me start the browser. So if you look at the if your browser is open, you can look at the so the address will be 127.0.0.1 and 5,000. This is where your server will be running. And if you go to this website, it should hopefully load up. It's too slow. Stuff from them still not working. Let's hope that it starts quickly. So, okay. Open. Oh, it's trying not to open up. already used. Let me open Firefox again. Some of these things happen always. Either slows down or code is not working at times. So in the meanwhile, let's go to some of the codes, some of the other things that we are trying to do, which is the second part of the code, wherein we have an error in it. And if you look at this part, which is a simple workflows, here we have parents equal to F1. This is how we link F1 and F2, so that the first one that is run is the F1, and then is the F2 that is run. So you see a name given here, and this name will give you some name when we see what is happening in there. So the second workflow that we are interested in running is to see what happens if there's an error in doing the execution. And this one over here will be a runtime error. And if I go to this definition of errors, and I should have probably gone. So if you run it, if you see the task which is optimize error, so the error over there should come from a runtime error. And this happens because we would give it a file over there, and that file would not exist. So let me just scroll up. And this is the thing that I'm talking about. So in the error, it'll try to look for water.xyz, and we have not provided the file for this task. So it should give us an error. Okay. So there'll be error because of this file, and we'll see how that thing changes the output that we get from there. So at first we'll see we have some fireworks running. Okay. So let me just kill Firefox in there, and Firefox is messing up. Let me also kill the other one, and then so let me start the web GUI now, and run. And we'll see what the first task looks like for us. So in the meanwhile, we'll go ahead and add another task, which is the run error in runtime, and we'll run that with the run workflows. And instead of a simple workflow, we'll replace this one with the run workflow. At a time, run workflow, and then let's see whether the Firefox is working. Okay. So we have the dashboard, which is loaded now, and let's see what it looks like. For the first task that we have added, which is the simple fireworks. And we have three things added in here, and we look at the simple workflow. You'll be having three links or three things attached one below the other, and the first one is going to run, and then the second, then third one. Okay, so there are a couple of browsers that are open. Let me just close one, and so let's wait for that thing to finish up. Okay, so we have 1, 2, 3 workflows, and each one of them, if we go into them, we'll see that this is the first one is optimization, the second one is Hessian, and finally we have TDHF. So we'll try to run these workflows right now, and we'll try to run that. And the command for that is launch, and I'll run all of them together. So rapid fire is the command. So when we do launch rapid fire, everything is will be run. And let's see what happens. So the first thing is one, which is the optimization task. You'll get a bunch of things in here, which is once it is optimized, the second task will run, and it'll show that it's running a task. So it started the Hessian task, if you could see that, and then now it's finally starting the TDHF task. And at the end, it shows the rocket is finished. And if we refresh this, all of them should be in green, and that shows that the workflow is successful. Okay. So now we'll go into the error part of it, where when things change a bit, where you get, instead of green, which you'll see right now once the page is loaded, uh, it'll turn red, and that is what we'll try to look at for now. So all of these would be completed, and you should see all of them in green. So let's go back to fireworks. You will see all of them in green. So now, let's now add the error one. So we have already added the error in runtime, and over here we have a file which is missing. So let's see what it does. Okay. So we don't provide the input file that is required, which is water.yz. So let's try running it. So when we add the workflow, we should not get the error, and the workflows will be added. And if you go back and refresh this page, you'll see that the error workflow is added, but uh, it does not know what the code is that is to run, but it just knows that it should run the optimization error task. So when it runs the task, you will see some errors. So let's go into this task and see what it has right now. Okay. So we have the work details. So we have FW name. It just knows it needs to run this, but it does not know what is within the code. So now let me run that code and see what we get. So I'll just run one of it. So I'll launch single shot, because I know that that code is going to fail. So let's see what happens. So once we run that, there's an error thing, and as you can see over here, it shows a runtime error unsupported atom water XYZ. So this is going to happen when you run it. And if you run it on HPC or something, you may not be able to see the error that we just saw, but this thing gives that error for you. So if you look into the thing, it says it's fizzled, and it says, okay, unsupported atom water XYZ. And this is the same error that you would get if you would run it locally or on a machine where you see something like this. So this is how things are done when fireworks. It also shows you the error, what is going wrong. Okay. So this is error that is raised by the program itself. But there may be instances where you want to raise an error because the structure is not optimized or something. And in that case, you want to raise an error. So let's look at a workflow which does that. And that is error raise workflow. So in this, what we are trying to do is we'll be passing in the optimized structure. We'll have optimization. And when we calculate the frequencies of the optimized structure, we'll see that there is a negative frequency. So that means that the structure is not optimized. So there is no point in proceeding to the next step because the structure is not good enough. So in that case, we will say we want to raise an error because the structure is not good. We just want to kill stuff. So let's look at the Hessian error task. So, and see what it looks like. So this is the Hessian error task. So we have a coordinates and everything put in here, and it's going to optimize this. And once it optimizes, we are going to look at analysis data. So this analysis data gives us frequencies, and there's a key which says frequency error. So frequency error, if it is zero, it would mean that your structure is well optimized. But if you have a negative frequency, the frequency error value is greater than zero. So these are the things that the program will not capture for you because the calculation was successful. So we would need to check for the data itself. So this is how we could check is an analysis frequency error is greater than zero. So in that case, we raise an error, which is we say runtime error, structure not converged, has imaginary frequencies. So this is the error that we expect to see because we want the things to stop at this point and give us an error that structure is not converged. Yeah. So let's go back and make this into error and raise workflow. Okay. So now let me execute it. Python workflow. So it has added the workflow, added it to the workflow. Let's go back to the web GUI and see whether it's working. And we should see up the dashboard which says error, raise error. And the second one is the one that will be raising the error now. And let's see what happens. Okay. So I'll run a rapid fire because we need to run everything together, not just one, because it's the second one that is running. So I'll launch rapid fire. So the first one should be successful. So you see that it is running. And the second one, it should give us an error because the frequencies itself, if you look at, I can show you the frequency dictionary over here. So it says frequency is 1, and there's a negative frequency in this case, which means the structure is not well optimized. So we raise an error over here, which is structure not optimized correctly, has imaginary frequencies. This is the same thing that we wrote in the code and we see it over there. So if we refresh this, we'll see that the same error is over here. Loads and it loads, and you can see over here runtime error, structure not optimized correctly, has imaginary frequencies. So this is the case where you have errors in, you want to raise an error because your structure is not correct. The other one that we saw was because the program encountered a runtime error. So do you have any questions on things that we have done so far, or anything that you didn't understand? You can ask me or type it in the chat. So let's go to the other one, wherein there is no error itself. In this case, the structure was not optimized, so we thought we should raise an error. But let's go to another scenario where cannot remove that error until you satisfy the condition that it requires. So in that case, we can do something else, like something called diffuse. So what diffuse does is it stops the workflow temporarily. And if at all you think that you want to continue the workflow, you can do it. But in these things where we fizzle, as you see, so if things fizzle, uh, it's not possible to continue the workflow because it will not allow it to continue. But if you want to diffuse it, say we just want to do atoms which are molecules which are less than 50 atoms right now, and if we have time later on or resources, we'll start the other ones if possible. And if we want to do something like that, we will use something called diffuse workflows. Okay, and that is where something a bit more complicated thing starts happening. And we'll start with optimization diffuse workflow. So we'll look into the tasks, and there should be um, so this is the workflow that will be running. Almost identical to the earlier uh, tasks that we had, but over here we are putting in a restriction that if the total electrons in the molecule is greater than 2, we will not run the things which follow this. So this is a parent. If you remember how we had set this up. So other workflows had this as a parent. So when we say FW action, so we need to return something. In the earlier cases, we did not return things. So if you return a FW action and say diffuse children equals to true, it will stop the workflow for you. And it does not erase an error, but you can start it whenever you want later on. But for the time being, it's stopped. And this is how you do it with the FW action. And it has a parameter called diffuse children and set it equal to true. So let's go and run this workflow now, which is diffuse workflow. And let's see what happens. Okay. I add Python run. So it should add everything in here. And then let's go back and refresh it and see what happens. So diffuse workflow is added. So let's try to run it. And by the thing that we have designed for right now, it should run the first workflow, and it should check whether this condition is satisfied. If only if this condition, which is total electrons is greater than 2 is satisfied, it's going to diffuse it. And because we have a water molecule, it's definitely more than 2 electrons in there. So let me launch it and see what happens. So the first one would be running, and it should run without an error. And then yeah, So it should say rocket finished. Though we ran the rapid fire, it just stopped here. And if you go back and see what has happened is you'll be seeing that the first one should be green and the second one is now gray in color. It's diffused. It is not giving you any error, and if you look into that, it'll just be as it is, right? State is diffused. So if you want to run it, you can run it, and the way we do that is you can get the FWID for this. So FWID is 11. So if you want to run it now, okay. So assume that you have done all the calculations that you needed and you have some computing resources available and you want to run this molecule. Or you come back and say that, okay, maybe this molecule is good enough to be evaluated. So what we do is LPAD, and LPAD has an option of ignite and ignite FWS. And we are going to ignite a firework and minus I for IDs. So ignite firework, and we are going to ignite the 11th firework. And this 11 comes from the FWID I just copied here. Okay. So this is the ID that is needed. The FWID ignite. Was it ignite or reignite? I think it's reignite. So you see now it's reigniting the firework. And if you go back to this, so now right now it's diffused. So when I refresh it, it should become ready to run. So let's see whether it works. Yeah, you see. Now it's ready to run. And if you want to run this, I'll just go back and yeah, I'll go back and launch the rapid fire. I'll launch a rapid fire. So this is going to run it. As you see, it's taking the Hessian task and running the Hessian task, and finally running the TDHF and completing the workflow. So let's see what has happened. It should show completed and should have a bunch of things in here, but yeah, it's completed as you see. So this is the difference between a diffusing and raising an error. Raising an error is because you don't want to run the workflow at all because something is wrong with it. And in the other case, you don't want to run it temporarily, but if you want to start it again, you can start it. And that is how you diffuse a workflow and continue. So let's go into the okay. So we had diffuse workflows, and let's see about passing parameters. Okay. So in none of these we passed things between the workflows. What we just did was every workflow had thing with inside it and the geometry inside it, and it just ran that geometry. But what if we want to pass the geometry that was generated in the optimization workflow to the Hessian workflow? So in order to do that, we again use the FW action. So let's see how we do that in here. So we have the coordinates given in the first task. Okay. So pass parameter task, we have the coordinates and everything in here. So now we optimize the structure. And what we do is instead of diffuse workflows that we used earlier, we use this update spec. Okay. And update spec, and we call it optimize geometry. We need to pass in a dictionary here. Okay. So when we use update spec, we need to pass in a dictionary. And because we need the coordinates of the optimized geometry, what we would need to do is, let me just replace. So we have some geometry here that we used, and then we are going to pass it, and this is how we pass it onto the next molecule. is we pass in a dictionary, and once it is passed, the corresponding uh, Hessian task should change. So if you look at that task, which is Hessian pass parameter task, you see that we now take the mole string that was passed and we use the FW spec over here. Okay, this is how we get the things from there. So we use FW spec and optimize geometry. So this is the same keyword that we used above. And once we have this, we can pass in and build the molecule from there. So this part is building in a molecule, but I'll show this part wherein we get a string from from the previous workflow and how that is updated. Okay, but it is between the fireworks that you pass it in. It does not go to the third firework, which is TDHF. Okay, so over here I don't use the FW action to pass it. So the next fire task should not get the optimized geometry. Though I have written a task for that, which does the same thing, gets the optimized geometry, but this should not work and it should give us an error. Okay. So let's see what happens when we run the workflow. So we have diffuse, so let's pass parameters workflow and go back to the terminal and let's Python. We have added it. So let's go back to this and see whether it works. Yeah. So, so the first one is going to pass to parameters to the second one. So let's look at the second one and see what is happening. Okay, this is the initial state now before the first one is run. So I'll just run one of the tasks. So I'll use launch single shot and let's see what happens. Okay, so the first one should run now, and once the first one is run, we need to pass in some parameters into this. So once we refresh this, you'll see some parameters added to this task. Okay. So the first task is completed, and let's refresh it now. And you'll see the task passing some parameters to this now, right? So you see the optimized geometry that we had is passed in here as a string. So this is the keyword that we used, if you remember. We use optimized geometry, and it gives us this thing in there. So now this firework, which is Hessian, which is going to run the Hessian pass parameter task, has access to this geometry. So that is how we get the if we use the FW spec and pass in this uh, as a key, so that we get the thing that is in here, and this task should run from here. And if you remember, we did not pass any geometry for the Hessian. We do not have any inbuilt geometry for the Hessian task, but we instead use the first geometry that was passed. So let me launch rapid fire now so that everything runs. And if you remember, we don't pass geometry from Hessian to the other one. So the last workflow should fail for us. Okay. And let's go back and see what has happened. So as expected, the last thing has failed because the Hessian task did not pass in the FW action, okay, an update spec. And if you go back into this and see the task, so task does not have the optimized geometry. While the earlier task, if you go and look at it, so in the spec part, so if you go to the spec part, you see the optimized geometry. Okay. So you just pass within workflows and you can't pass throughout the workflows. So if you want to do that, there's a way to do it. But if you use FW action and the thing that we have used in Hessian, the optimization task, it is only applicable for passing things between a workflow and not through the entire between two fireworks and not through the entire workflow, if that makes sense. So do you have any questions or something that you did not understand about this? If not, we will go into the other other workflow, which is user parameters. Okay, so instead of things passing, instead of the optimization taking geometry from within the code, what if a user wants to pass it? So if we want to use something like this, we can pass parameters over here. So over here, as you see, I'm passing in mole chords, and this is the coordinates that I'm passing. So let's look at this user parameter task, optimization user parameter task. So if I go to tasks, and let me just bring this. So the difference between those things is this is the task that we are interested in. And if there's a user pass parameter, for example, you are passing in parameters from this point, okay? We are passing parameters to this task itself. That would be, if you want those parameters, we use self, okay? So we use self and whatever we give the name to it. So over here, if you look at it, we say mole coordinates, mole chords, and the same thing should appear in here, self of mole chords. And this is very different from the Hessian thing, okay? So over here, when we use FW action update spec to pass things to the next workflow, we don't use this self, but rather we use the FW action that we pass. So there are two things that we pass in to a task, right? So one is self and the other one is FW spec. So if we use the FW action to pass something to a firework, we need to use FW spec to get that. But if a user passes it or we pass it through the function call, we use the self one. Okay. So because we passed now the coordinates through the through the task itself, so we would need the self dot mole coordinates. Okay. And the corresponding you the task, which is the pass parameter task, is going to take in parameters from the first one and then do the thing. And as you know that the Hessian task does not pass in parameters to the final one, it will not change things. So the final task um, should be an error in the final task. Okay. So that's how we pass in user. uh, just show you the difference of what's happening in there, and then I can workflow. We add it, and I'll just show you the difference. I want to run this workflow right now, and we'll run it later on. So user parameters, and if you see the first one that we have in here, we should see mole coordinates now within the task, and these are the coordinates that we passed in. So if we use self, it's going to take in this mole coordinates and run the task. Yeah. And the rest of it is very similar to the last thing that we did. So this is for the if you pass the parameters through the task, you need to use self, or if you use the FW action, you'd need to use FW spec to do stuff. Do you have any questions so far? Because the next thing that we are going to do is write things to a database and see how we can do that. Any questions? So we will finally go into the workflow which writes stuff to the database. Okay. And in this, we are going to use the Hessian one, which writes stuff to the database. And the Hessian write to DB is going to use, what we are trying to do over here is to get some thermochemistry parameters, but we are going to change the basis set. And the basis is a user input. So as you see, self, and we are going to set that basis in here as basis and then use the same molecule. And we don't change the molecule in here. And we get 0 point energy, CV, CP, and Gibbs free energy. And this is the code that does it. But the thing that we are trying to do over here is write to a database. And we want to write it to a Mongo thing that we created. So we would need to replace this code over here with the launchpad stuff that you have. Okay, so let me copy paste this. So you need to copy paste your host, and once you have the host in there, you can go to the what is it, task. So task and paste it in there. Okay, so this is the thing that you would need. So this is how we connect to a MongoDB instance. So we say Mongo client, we pass in the host, and then once we have a client, we need to get the database from the client. So this will be your database name. If you have a different database name, you can change it. And from a database, we need to get collections. So collections, let us call the thing that we insert results as a results collection. And this is the collection that we have. So if you want to insert something, you can use this command for MongoDB. So that will be collection and update one. So a MongoDB requires the underscore ID field in a dictionary. So what we are going to do is pass a dictionary. If you had a chance to look at what MongoDB looks like, it's all this, it's like a dictionary of Python that is in there. So it needs this field called underscore ID to uniquely identify each document. And if you remember, MongoDB is a document database. So it needs this underscore ID as a unique thing. So because we are going to change the basis set for each of these ones, I'll be using basis as the ID for this. Okay. And ID for this, and then the data that you want to push into database, we need to use some syntax like this. So this will be the first bracket, which will have something like this, and the second one should be set and data. So your data should again be everything in a dictionary, and you can put in a list into it. You can put in strings, you can put in integers, floats, and other things, but you cannot put in numpy objects or something like that. Okay, so because it's not JSON serializable, that's something you need to take care of. But you can pass in lists and you can pass in dictionaries if you want within this, but not any other objects. So this is how it's going to push our data. So our data into that. Okay. And upsert equal to 2. So if you use this thing, it should usually work. So we'll use this. Okay. And if you see the one workflows, I have already defined the list of basis sets that I'm going to use. And let me loop over this now. So for this, what I'm going to do is cut and paste. Okay. So I need that command, and then for basis in basis set, I'm going to run this workflow. I'm going to run the write to DB workflow, and the write to DB workflow requires basis. So now basis equals basis. And if you look back at this workflow, what it looks, if you look back at this, I pass in basis to this fire task, but that basis comes from this function call. So I pass basis, and that basis goes here, that basis goes there, and that is how it works. So now I use this, basis is this. So let's try to run this. Okay. So now it should run 1, 2, 3, 4, 5 workflows. Okay. And let's see. So Python. So you see, 5 of them have been added, and let's go back and see what it looks like in this. So you see workflow, def SVP, CCPVDC, a bunch of workflows. Okay. So all of them should do the task of writing stuff to the database. And let's see how that thing goes once we launch RapidFire. The earlier workflow will be running first, which was yeah. Let's see. The thing is being written probably. So let's see how things are going. So it's going to run this. Hopefully it works. Yeah, you see, these things are running, and let's see. Okay. So those things are run, and you see the user parameter part will also be running, but the last thing is going to be failed. So, and that failure is because of the parameters not in there. Okay. So yeah, because this the Hessian does not pass it parameters. But yeah, so this is where you insert things into the database. Now, what about getting things back from the database, right? That's what we need, because if we run hundreds and thousands of workflows, we need stuff back from the database, or we need to be able to search it in the database. Right? So let's go to the task. I open a client shell here, and let me copy paste this entire thing. Okay. Results. So over here we did the insertion. So now let's do the finding one. Okay. So if I do collection dot find underscore one and just given an empty thing like this, it should pull a collection from there. Okay. Because I'm just finding one, it is just going to find a collection. So I can say find one. Now if I need ID, so ID, if you remember, is the basis. And if I let's go back at the basis that I used and see what basis I had in here. Okay, so I have STO3G 321G. So if you need an entry for 321G, find one, and the ID is 321G, and this should give me an ID of 321G and the corresponding data for that. So this is how we are going to search the database for things. So if you want 631G, you can just go and type in let me see what format it was. Okay, 631G, and this should give the data for 61G. But if you are in a mood to have nice table made out of it, what you could do, there is also, you can use collection dot find itself, and then this will be a list of things. Let me call it cursor. So it'll be a list of all of them. And then if you do cursor of 0, it should give you the first entry, and then cursor of 1 should give you the second entry, and so on. So you could loop over this if you need, okay? And that's how you're going to do it. So you do find, and it's going to find everything for you, and then you can do it. You can pass in queries into it and say that where some value equals to something, and do that. But if you're interested in getting a nice table for you, okay, so in that case, what you could do is, if you're familiar with pandas, so let's do that here. Yes, and PD. Okay, let me import pandas, and we can pass in this thing the cursor that we created into pandas, and it'll create a data frame for you, so you can do analysis very quickly with this. So let's see, let's create the cursor again. Okay, so I do cursor is this, and then I do pd dot data frame, and I pass in the cursor. There's something called from records that you need to use. CORDS from records, and then use cursor. It should give you a nice little data frame here, which is IDs, and these are your IDs that you want, and this is the CP. If you remember the things that we added in, and you can do a bunch of machine learning or data analysis from something like this. So as long as you have nicely arranged data in the database, you can get something like this, and you can see that CP, CV don't change much with the basis set, but the Gibbs free energy and 0 point energy do vary a bit. And you can see a lot of difference if you use STO 3G and the other basis sets, where there's a change in around 3 units, 0.003 units in this. But yeah, this is how we are going to write stuff into database, and also we wait from the database to do the analysis that you are interested in doing. So yeah, I think this is all I had. Uh, I wanted to cover this in the previous workshop, but due to uh, we are running out of time back then, so this is the extended one where we have some things discussed. And if you have any questions, let me know. If not, we will end this workshop. Let me stop the recording.